Hello everybody and welcome to today's lesson on angles and their measure. Today our objectives are we will be able to draw an angle in standard position, find coterminal angles, and convert between degrees and radians. What is an angle and how do we label it? An angle is built from two sides that meet each other at the vertex, and between those two sides is the actual angle. In trigonometry, we label these sides. The bottom side we call the initial side, and the top side is called the terminal side. And where they meet, we have the vertex. And that way we create an angle, and we use Greek letters usually to name those angles. The Greek letters that we use the most are alpha, beta, and theta. And this angle we'll call alpha. So when is an angle said to be in standard position? An angle is in standard position if the initial side is on the x-axis and if the vertex is at the origin, so at the point with the coordinates 0 and 0. How do we measure angles? We actually have two different ways to measure angles. One of them you have already learned, and that is in degrees. And you remember that going around the entire circle would be 360 degrees. And the other new way to measure an angle is in radians. Radians don't measure so much how wide the angle is actually open. What they measure is the distance around the circumference of that circle. As you know, the circumference of a circle we can calculate with the formula 2 pi r. And in trigonometry, we deal a lot with a circle that's called the unit circle, where r, the radius, is 1. So that makes the circumference of that circle 2 pi times 1, or just simply 2 pi. So 1 time around the entire circle is 2 pi units. Do distinguish, degrees always are measured in degrees and they have that degree mark. Therefore, radians are not measured in degrees. They're simply units of distance. Let's try this out on a couple of examples. Let's assume we have an angle theta and the measurement of that angle is 300 degrees. Where is that angle going to land if we consider that it's going to start at the x-axis? 300 degrees is quite a big portion. It's not the entire 360, but if we cut the 360 into 4 pieces, 1/4 would be 90, the next one would be 180, next one would be 270. So we're going to land somewhere further than 270, somewhere down here, and that is in the 4th quadrant. Our next angle, alpha, may be given to us in radians. And if its measurement is 5 pi over 6, where is that going to take us? Remember, around the whole circle is 2 pi. That means half a circle is pi, and 1/4 is 1/2 pi. 5/6 pi is definitely more than a quarter, but it's not quite 1. So this is where this angle would end up, approximately, the angle alpha, and that would be in the 2nd quadrant. Next, our angle beta is given with a measurement of negative 135 degrees. Negative means we don't go the way we usually do, which is counterclockwise. We actually this time go clockwise. Clockwise, definitely 90 degrees. Not quite 180, but pretty much halfway across, and that is where this angle would land with negative 180 degrees, and angle beta would be in the third quadrant. Now let's look at another theta with a measurement of negative pi fourths. And again, negative means that we are going clockwise as opposed to counterclockwise. Remember, 2 pi is a whole circle, pi is half a circle, 1/2 pi is a quarter of a circle, so we are actually going just 1/8 of a circle or half of a quadrant, and that is where our angle theta is going to be, nicely in the fourth quadrant. Our next angle beta with the measurement of 200 degrees, we are going counterclockwise again. For 1/4, that's 90. 2/4 is 180, so a little bit more than 180, which makes it approximately here, and that's 200 degrees, and beta lands in the third quadrant. Last but not least, our angle alpha with the measurement of 7 pi over 4. 7 pi over 4 is not quite 2 pi. That would be 8 pi over 4. We're going through the first quadrant, which would be 2/4 or 1/2 pi. Through the second quadrant, which would be 1 pi or 4 over 4 pi. Through the third quadrant, which is 3/2 pi or 6/4. And 1/4 more, and that would make our angle alpha land right here in the middle of the fourth quadrant. Okay, so now let's have a look at our angle theta in orange down here and our angle alpha. And even though the measurements look different, these two angles land in the same spot. Only theta went clockwise in a negative direction, while alpha went counterclockwise in the positive direction, but they both landed in the middle of the fourth quadrant, and we call that coterminal angle. Coterminal angles are angles that have the same terminal side. And we will look at coterminal angles some more in the second part of this tutorial. So go ahead now and watch that next.